Hi, everyone. I'm excited to share our work on LL-Localizer, a lifelong localization system built to tackle real-world messiness head-on. Powered by a dynamic i-Octree structure, this system is designed not just to localize, but to evolve. Think of it as a map that lives, learns, and grows with the world. Let's face it, localization is not a one-and-done deal. The world changes constantly. Cars move, trees bloom and shed, and robots? They venture into new territory all the time. So if we want long-term autonomy, we need maps that don't just stay accurate. We need maps that adapt. That's the essence of lifelong localization. But current systems? They fall short. GNSS fails in urban canyons and indoors. Many methods are built for static, clean environments, and break down when reality doesn't cooperate. Most importantly, they treat maps as fixed. Once built, they stay frozen. And that's a problem because the world never stops changing. Our answer? A dynamic i-Octree. This is a map that's structured into 3 levels, optimized for rapid updates and scalable storage. It lets the system know what to change, when and how, and seamlessly switch between localization and SLAM whenever needed. Now imagine a robot entering a brand new alley, one it's never seen before. Most systems would freeze. LL-Localizer doesn't. It expands the map on the fly. As the robot moves, the environment is integrated, real-time, no waiting, no panic. That's what we mean by lifelong deployment. And what about when familiar places change? Maybe that parked truck is gone. Maybe new construction popped up. LL-Localizer detects that and reloads the relevant map segment. It updates instantly, so localization remains accurate, even when the world surprises you. We tested this system on the Botanic Garden dataset, a tough environment full of uneven terrain and heavy vibrations. It's the kind of place that would trip up most systems. But LL-Localizer handled it gracefully, proving it can stay grounded even when the ground isn't. Across all our test sequences, LL-Localizer consistently beat the baselines. It had lower errors, better drift control, and remained stable even in dynamic scenes. The key takeaway? This system doesn't just work in theory, it holds up in chaos. We wanted to push it further. So we benchmarked it on NCLT, M2DGR, and Botanic Garden, each with their own quirks and challenges. No matter the dataset, LL-Localizer came out strong. It adapts. It generalizes. It handles the unknown. Because here's the thing, maps are never complete. Robots get lost. They go off-road. LL-Localizer is built for that. It doesn't fail. It explores. It fills in gaps and keeps the robot localized while discovering new terrain. It's like having a map that writes itself as you go. Now, all of this wouldn't matter if it were too slow. But thanks to the design of our i-Octree, we actually improved efficiency. Neighbor searches, block updates, latency, all optimized. That means smoother performance and fewer high-latency hiccups. Because fast is safe in robotics. Now, before we wrap up, let me show you a real-world example of LL-Localizer in action. In this demo, we're starting with a prior map, one that's partially outdated and doesn't cover the entire area. The robot begins its journey in a familiar region, but soon enters zones that have changed, or were never mapped at all. Watch what happens. The white points represent the original, static map. The red cloud shows the robot's current LiDAR scan. And the green points? Those are newly discovered areas, automatically integrated on the fly. What you're seeing is the system detecting change, expanding coverage, and updating the map in real time. No crashes. No resets. Just smooth, adaptive localization. This is exactly the kind of resilience we need for deploying robots in real, dynamic environments. So, what's the big picture? LL-Localizer is more than a system. It's a step toward making autonomy truly reliable, truly adaptive. A robot that remembers. A map that evolves. And localization that lasts a lifetime. Thanks so much for listening. And if you're curious, check out the paper.